Good afternoon, everyone. My name is Paul Keys, and I'm the facilitator for today's webinar. Today, we're going to be talking with Curtis St. Michael from Idaho National Labs about an introduction to cyber-enabled sabotage and engineering protections. So before we begin, we've got a few housekeeping items to cover. If you're trying to connect through a VPN, you may have difficulties, so we recommend that you ditch the VPN and you connect straight to the webinar. Also, the audio is going to be broadcasted through your computer speakers, so that should have happened when you entered the session, and you should have been prompted to connect to the audio stream. Just click connect and turn up your volume. Next, you want to use the chat tab on the control panel to submit any technical issues. Look at the private tab for your response. Also, please submit a written question anytime via the Q&A tab. Upvote any questions that have already been asked to avoid duplication. And it will certainly let us know that we want to ask that question and get an answer to it. And then lastly, this webinar will be recorded for future viewing. We also wanted to note that we have several handouts that are available, and you should receive those. Okay, I believe, yes, a PDH cert will be sent after the session, and I believe we are going to kick things off with a introduction poll, just to let us know who you are and where you're from, and that'll help us as we present this material and answer questions. So, guys, if you want to kick that poll off, and Curtis, I will hand it over to you.
Thank you, Paul. You said I'm Curtis St. Michael. I am the technical lead for cyber core programs at the Idaho National Laboratory and a senior control system security consultant for the Department of Energy. Over the last 30 years, I've had a unique opportunity to work on a wide spectrum of electrical, instrumentation, control, and communication systems in support of nuclear facilities, critical infrastructure, and other national security challenges. Control system cybersecurity has actually been my primary focus for the last 21 years. I've been involved in programs across the USG from Department of Energy, Department of Homeland Security, and DoD programs for that entire time. So, and as part of this, my colleagues and I have developed a framework for what we call consequence-driven cyber-informed engineering, or CCE. And this is a methodology that helps you break down kind of how cyber could affect your critical functions. So I've spent the last 7 years working with both U.S. government and industry partners to help establish this program and to address the cyber risks to national security. And my main job now is to train staff to stand up this center for this type of innovation in this area. Okay, let's see here. Okay, so I'm going to take a few minutes now to examine why you're here and why we want you to learn and adopt a new approach to protecting our critical infrastructure and national security missions. So, as y'all know, listening to the newspapers today or any day, we continue to be attacked and exploited. I mean, every day we hear about and increasingly we experience attacks that range from anything from criminal groups implementing ransomware to nation state attacks that are executed to achieve military or political objectives. And these attacks are starting to affect nearly every aspect of modern life that we depend on, from our drinking water to fuel for our vehicles to the underlying electricity supply that we rely on for everything from industry to the lights in our homes. And this is happening despite the ever increasing budget and focus that is placed on cybersecurity. And the fact that in most of the organizations that we support as engineering professionals have many of the latest and greatest operational and security technologies for controls, communication, network monitoring, endpoint protection, access control, vulnerability identification, asset management, logging, alerting, et cetera, et cetera, et cetera. Despite all of that, and the fact that we're also really starting to map and follow the tactics, techniques, and procedures of known actors. I mean, we're seeing this ever increasing ramp in both the type of attacks and the effect that those attacks are starting to have on every aspect of modern life. And so we have to ask at this point, what are we missing? And what we are proposing is that what if the cyber impact to the functions that we really depend on is not really a problem for someone else? For the longest time, most of what we do as engineers or operations folks, the people who actually help put together and support critical functions, whether it's critical infrastructure or military, lifeline services, or those functions that support the economy of regions. Cybersecurity is something you do in addition. That's for, the cyber guys to do. And we expect our vendors to be providing secure components. And, it's everyone else's problem. But we take a step back for just a minute. I want to think about, what do we mean by critical functions and what's changed? So over the course of this presentation, I'm going to talk a little bit about, what has changed from 10 years ago or 20 years ago when we provided critical functions across our infrastructure for national security, and today. But in addition, I want to think about this idea of cyber being someone else's problem or something else, because increasingly, if we really look at it and peel the layers back and start looking at how we provide critical functions today, and we start to look at the effects that are happening, you start to realize that the way that adversaries are starting to affect critical functions is because they are exploiting how we deliver them. And when we say how we deliver them, that's how do we design, how do we build, how do we operate, commission, maintain the systems that are critical to nearly every aspect of our lives. When we say enabling functions that provide that, what are we talking about? Well, I'm talking about technology. Obviously, we have become very reliant on technology, and we've started to incorporate digital technologies into every aspect of our lives. But in addition, it's also the people and the processes that do that. So people, let me go just a little bit into that. So when I started at the lab 30 years ago, I went out to work at a nuclear fuel reprocessing plant in instrumentation and control group. And there was about 65 of us, and we supported a plant that had 7 major processes, and we basically worked with the engineering groups on those processes. We worked with the operators who were operating those processes, and we designed, built, and maintained all of the technology. So all of the boards, we wrote all the software, we often wrote all the procedures and all those kinds of things for maintenance, for operations, etc., across that. And in the course of 10 years, while I was there, that group of 65 of us went from 65 to 5. And pretty much every one of those systems that had been, we'd started building and designing those in the late 70s and early 80s. Those all they were custom installs at that point. When I got there, we basically replaced all of that with commercial off the shelf technology. And we started to expand who provided all that support and where that support came from. So much of what we do was no longer about the capabilities that we had in-house. It was the capabilities that we could buy from vendors and subcontractors and others. So when there's a problem in the field, it was no longer about I could go down, to the desk across the aisle and say, "Hey, Bob, remember when you designed this board?" Or, "Janice, when you wrote this algorithm for this control function, now I'm working with vendors and others." And that has really changed even in the course of my career, just the last 30 years, where that all comes from. So those people who actually provide the detailed engineering or support operations, as well as the technology that we're using and the processes that we use in order to provide those critical functions, have all changed drastically. They may look similar, they may provide similar functions, but the digital devices of today are not the same as the electromechanical devices that I was deploying when I went to work. Those electromechanical devices were pretty singular in their use. They were purpose designed. And we understood a lot about them. We understood through lots and lots of history exactly how they failed, when they failed. We could really understand everything about them. And if you're really smart, you can understand, if I put a whole group of those together, how those will fail. But they were closed systems of devices that we could really put our hands on and understand. Well, over time, we've slowly taken every one of those devices out and replaced them with a general purpose device that has a whole lot of capability that we are configuring for a very small function. And then we're testing them in the same way, and we're using them in the same way that we used electromechanical devices, but they have orders of magnitude more capability. And that's a really good thing because I can reduce my costs. They're much more reliable. There's all kinds of really good advantages to both that technology, the fact that I can now rely on experts from different organizations or vendors to help me support that. That makes everything cheaper, more reliable. There's a whole bunch of things that go along with that. But on the flip side of that, there are security implications when you do this. Um, and we're going to kind of go into those security implications. And I really believe a lot of what we're seeing today of adversaries exploiting that how and the impact to our critical functions, it means that we may need to question how we're doing business and maybe change how we're doing engineering and operations. So let me start with critical functions. I'm going to go ahead and define this. It may seem pretty obvious, but the critical functions are the actions or activities that make up an organization's primary mission or purpose. And um, so much in the security world, we end up focusing our time and efforts on a particular technology or a particular piece of the threat or some other piece of that, and we start to lose focus on we're looking at the details of technology or what the current trends for cyber exploitation is and all those kind of things. We kind of lose focus on what are we doing with that technology and how we're using it. We're doing this to provide a critical function. We're doing this to move refined petroleum products through a pipeline. We're doing this to make sure that clean water is where it needs to be. We're doing this to make sure that goods are transported from where they're manufactured on rail or in shipping to ports on the other side or unloading those ships. So that function is and needs to be a critical part of how and where we look at the security challenges that we're facing. So when we think about these critical functions or that organization's primary purpose, then again, the how of how we provide that critical function is what we term people, processes, and technologies. We focus a lot on the technologies, but we also have to think about the people and those processes. When I start breaking down how an organization provides a critical function, I really almost start with an org chart of engineering, operations, maintenance, communications, etc. And for a critical function, I'm really thinking about asking a question: who, what, a set of questions: who, what, where, why, when, and how do these engineering functions happen as related to this critical function? Who does them? Who programs your relays? Who comes up with the model that's used for the settings for those relays? Who does those maintenance functions? 20 years ago, that was all inside. Today, that may all be done by different organizations, and there may be opportunities for adversaries to take advantage of that from a security perspective, where we're just considering it the same as it's always been. And that's where we're starting to open ourselves up to a difference in how an adversary can exploit us from a cyber perspective. We're talking about exactly how logically and physically that we deliver it. So a lot of processes and things now aren't even done locally on at a device. Like a lot of the monitoring for HVAC systems is now done remotely. Those systems have a lot of monitoring capability, but a lot of the number crunching and really understanding where maintenance, when and where maintenance should be done and all that, that's done off premise. in the cloud. So we're collecting a lot of data, and a lot of those functions are being done completely separate from the equipment that we're relying on. And understanding that those functions are no longer just this HVAC unit that's sitting in my facility, but a whole different organization that's monitoring it and different people that are involved. That's part of what we need to consider when we're really thinking about how that critical function is being provided. In this case, heating and cooling for a facility, let's say a data center or something like that. Um, it's got to include the whole life cycle and the logistical ecosystem that goes into providing that life cycle, from design to commissioning to operations and maintenance, and all those support functions that go along with it, and really pulling the thread on those critical pieces to understand exactly, again, what people, what processes, and what technology are used to do those. Other thing that is a struggle and what makes it a little bit different from traditional cybersecurity is that these implementations are unique. Um, Although many of the technologies and are ubiquitous, the application for exactly how they're used in a particular to provide a particular critical function is relatively unique. So I can have the very same technology applied even in the exact same uh, vertical, like transportation or electric power generation, and how that technology is used, um, how maintenance is performed or how an operator is empowered to operate that equipment may make a huge difference in whether an adversary can take advantage of the technology in order to upset or cause an impact to that critical function. One of the really classic examples of this is the difference between how electric power, particularly like distribution level electric power, is done in the United States versus a lot of other places in the world. So in the United States, we have optimized our control systems and we've minimized the number of people. We have much more reliable systems. So we can run multiple, sometimes dozens of substations, monitor them all from a central location, and then we're able to dispatch a smaller number of electricians or others to maintain things as things go wrong. Um, and that's really good for efficiency. The equipment's better, um, helps with our costs, but that those good parts have a downside. So in 2015, when the Ukrainian distribution systems, 4 different distribution companies were attacked, an adversary went in. They went in and actually got onto the systems at these distribution control centers, and they opened up all the breakers in the substations. Well, the Ukrainians at that point had a very different model that they were operating under. They had not gone through this optimization cycle. So although they did have overall control centers that monitored an entire utility, um, those control centers really were more about collecting data and taking overall health. The actual control and operations were distributed still to distribution control centers that had maybe a dozen substations on each one. So when the adversary attacked at those distribution substations and opened up all the breakers, well, each one of those distribution control centers was able to send out electricians to go out and actually recover the system manually in about an hour or so. Whereas if we'd had that same attack in the United States, it would have been a much more difficult and much more impactful set of outages. So again, how we're using that technology, even if the technology was exactly the same and the attack scenarios were the same, the impact can be very, very different. Is there any questions I can answer about these enabling functions or critical functions at this point?
Curtis, we don't have any questions on the board yet, so we want to encourage people. If you have questions, please post them to the Q&A section of the board, and we'll go ahead and get those answered. But Curtis, I've got a question. So,
Okay.
I know you've done a lot of work with DoD and looking at DoD critical functions and that sort of thing. And can you give us some examples, general examples of what you've seen in terms of critical functions or enabling functions within the community that might resonate with the SAMI membership?
Sure. So let's just take a couple right off the top. So I know a lot of folks are going to support or could support facilities that have data centers or pieces that are associated with that. And as a matter of fact, I've been looking at a couple of different facilities lately that deal exactly with that. And so when you're thinking about that, you're thinking about that data center. One of the critical aspects of a data center is your heating and cooling for that data center. And so everybody gets, you start thinking about that. Well, how does that HVAC run? I've talked about oftentimes that HVAC is going to be monitored by external entities. There's a whole bunch of things about that HVAC system itself and the control of that heating and ventilation system that's important. But even more important is there's also supporting infrastructure that goes with that, like the power to that HVAC unit, or the water supply to the cooling tower for that HVAC unit. Those services are critical to providing heating and ventilating, and oftentimes those layers and understanding how those are interconnected and who's responsible for providing those. I can, as a bad guy, I could attack or affect an HVAC unit, but I could also affect the power and standby power that provides that, or I could affect the water supply that comes to it. So there's a lot more to understanding that attack surface than just the straight function. You got to break it down and understand all the supporting functions that go with that. Another would be things as simple as like ports, transportation, critical link. Very timely, that's a real choke point in the supply chain interruptions that we're having around the world right now. Now, there's other reasons for that, but we've got ship after ship sitting on the outside, and we've got some other issues as far as personnel and just timing and getting ships unloaded. But imagine if we add in the fact that our cranes don't work, or the units that load the trucks, don't work, or even better, that the information systems that tell the people unloading off of ships or putting something onto a truck or a train, they lose all the data and they have no idea where that goes.
That would never happen, would it?
No, that would never happen. But those kind of things are exactly what we're talking about is, um, and so if I'm thinking about security of some of these functions, I can break down these functions into what am I trying to do at this port? I need to unload uh, stuff off of a boat and put it on a trains or trucks. And so what's everything I need to do that, and where are the choke points in that? Where do I rely on technology? That can for those different operations, and that can give me a focus for where do I need to focus time and energy to assure that that function will continue regardless of whether somebody is attacking an information technology system, etc.
Okay, great. Curtis, we have a question from Gary. I think Gary's down in Charleston with the Army Corps of Engineers. His question is there some critical function or are there some critical functions that are so important that the best option is to isolate them off the internet?
Yes, but having said that, isolating something from the internet is very different, and we're going to talk a little bit about this. Is if you incorporate digital technologies into your critical functions, there is no such thing as isolating a system. And we're going to talk a little bit about what that means, because not only has technology changed, but how and where, because you have digital technology, I am not limited to attacking, or an adversary is not limited to attacking a system through the internet. A digital device has all kinds of connections to it during maintenance or configuration or any other things, or even when it's manufactured at the vendor that provides it. All of those provides opportunity for an adversary to insert malicious code and put it in. So at this point, you basically have to consider, if you use digital devices, that an adversary can and will get into those devices, and you have to understand what will that mean. And that goes to this next slide, which is an adversary is going to exploit um, any trust we have in devices or people or processes in order to uh, impact critical functions. Um, and that's where we need to be focusing our time and effort, is really understanding how we're relying on those technologies, and then thinking about, is there a different way that I can use those technologies in order to assure that critical function regardless of whether it is compromised. So what are we talking about here? I'll give two examples of functions that, if I talked about the critical functions of shipping, a lot of, or the operational technology that's used in shipping, people would immediately go to engine control systems, or, like I said, the cranes that load or unload systems, et cetera, et cetera. But if you actually look at what's involved in global shipping, there's a whole lot of things that are really important to that. And we actually had a demonstration of this with the NotPetya attacks a few years ago. NotPetya was uh, an attack that looked like ransomware. We believe it was a nation state sponsored attack that had collateral damage across a whole bunch of industries: food, banking, and in this case, shipping. So Maersk had a bunch of their information technology systems that were uh, compromised by this pseudo ransomware that locked up their systems. It spread very effectively, And they basically, without the information from these systems, they could not tell where anything should or would go. And it basically locked up global shipping for a couple week period for Maersk. So this is an example of you have to break down and really understand how do you provide your critical function and understand if I don't have uh, this information from these systems, how would I continue to operate? What they ended up doing was rebuilding, people using personal phones, printing stuff out. They were able to start to recover those functions, but the time to do that is not in the middle of a crisis. The time to do that is to understand how can I continue to operate through if I don't have access to this technology that I depend on. Very
You know,
similar thing happened with Colonial, where the Colonial Pipeline, again, criminal ransomware in this case, against the company. Why did they go against Colonial? Because they provide a critical function and it's important. And so they're probably going to pay. And so, even at the criminal level, they didn't intend to shut down a pipeline. But the fact of the matter is, the reason they targeted them was they make a lot of money providing a critical function. Um, the ransomware was in there, to all accounts, was in their information technology systems. And no one, even a month before that, would have said, oh, yeah, if an IT system is compromised at this company, that it would shut down refined product going through to the East Coast. But the reality was that without that information and without really understanding the level of surety necessary to make sure that they were getting what was supposed to be where it needed to be and that they could operate, they had to shut down the pipeline. So, in effect, you sabotaged the ability to provide refined fuel by just locking up information technology systems.
Curtis, I believe this same group they haven't stopped doing that sort of thing. I think this month they hit a few oil terminal facilities over in Europe just a few weeks ago.
Yep. And that's all very interesting. So whether they're criminal organizations or um, nation state sponsored or some shady combination of it all of these things matter. And they are attacking critical functions because they can make money. And they may also be doing it at the behest of uh, governments that want to have an effect on the West. So, a couple of quick items to talk about where we were, which is in this aspect of traditional risk management, was there was IT organization and there was um, information protection. So we wanted to protect our information, our intellectual property, those kind of things, and so everything was built from an information assurance perspective. This is confidentiality, integrity, and availability of data. And those are very important aspects of information, as we can see from the previous examples. However, um, those same measures don't apply in the same way, nor would those considerations be incorporated in traditional operational technology that was used to run critical functions. So critical functions, um, when I started this out 20 years ago, when we would talk about like electric grid security at a conference, it was about reliability, having redundancies, and those kind of things. And if we talked about security from a traditional sense, it was more about physical security, physically isolating it. Again, because the technology we used and how we provided those critical functions, you pretty much had to have physical access or a discrete understanding of every single installation and the electromechanical devices involved. Well, since that time, we've evolved. We've evolved from where digital technology is primarily used in very similar ways for information assurance to, I guess I'm missing my other slide, to uh, where we have uh, digital technology incorporated into our critical functions, and those critical functions and that traditional way of assuring, either from a physical perspective or just from a redundancy perspective, no longer applies. And it could be argued that information assurance actually is kind of a subset of critical function assurance now. In the case I just showed you, um, understanding how and where information is critical for global shipping or providing a refined product is really, really important in order to uh, make sure that those functions continue. Um, and so the amount of spend that I would do on protecting that particular information may be greater than what I would spend in just a general case for information assurance. This kind of takes us to our next concept, which is cyber-enabled sabotage or a sabotage effect. And cyber-enabled sabotage is this focused campaign to impact an organization's critical function using cyber means. And those words are chosen so very carefully. Most people, when they think about cyber, they think about a vulnerability and an entity exploiting that vulnerability and causing an effect. But cyber sabotage, because it is impacting a critical function, which is always has some level of specificity to its implementation, is not about a single vulnerability in some system. If an entity, whether they're a criminal entity or a military entity, wants to impact a function, they're going to have a series of information collection, gaining access, and then taking actions on several systems in order to have that effect. So in Ukraine, it's believed that the adversaries started compromising systems 6 months to a year before before the actual events, in order to gain the access and the information they needed in order to have the kind of effects that they did. The other aspect of this is one I've mentioned already, is that an adversary is not limited to network-based attacks. We have seen many examples now where adversaries are using supply chain attacks, either from hardware or software, to carry their tools into an organization. So, in other words, they are at a manufacturer or at an integrator, inserting their malware in at that point, and then letting that malware carry in to the organization via normal processes. It's triggered in different ways, or rather than just a network attack, but those are ways that an adversary can get malware in. It can also do it by attacking any other subcontractor or other service provider all the way around that ecosystem of how you provide us, the enabling functions to a critical function. So we need to keep in mind that it's not just whether something's connected to the internet. It's if it's a digital device, it can and probably will be compromised. There's lots of different examples of this, but one that I really wanted to highlight is this is the Triton petrochemical attack in 2017. Safety instrumented systems are kind of the last boundary system that is for any critical process where you could have you could hurt a lot of people, damage the environment, or damage equipment. So you're talking usually triply redundant systems that had extensive failure mode analysis that's done for those. And it was believed for the very longest time that that level of redundancy and failure mode analysis, as well as the fact that these systems are separate from the control systems, would isolate them from these cyber type effects. But in 2017, we actually saw deployed malware against one of these systems where these systems are actually compromised. And luckily, in the case of this petrochemical attack, it was detected during the attack. But the mechanism that was used and the fact that there was deployed malware means that these last defense systems that keep bad things from happening, even when it isn't malicious, can and will be compromised. And this is a real game changer to understanding that even some of these mechanisms that we believe were from a failure perspective or others, they can and will be attacked. And once we do that, there's absolutely no reason to attack a safety system other than to have a physical effect. The only thing it does is keep bad things from happening. As a matter of fact, just compromising the safety system will cause nothing to happen. You would actually have to couple this with a physical attack or a different cyber attack in order to have an effect on the system. You're also not going to get any intelligence value out of it. You're not going to learn some secret process. This is all about having physical effects. And the fact that this is out there and doing it really highlights the example that this is out there and you have to worry about it.
Curtis, I think with that attack, didn't they have some other attacks that occurred a week or two or a month before the actual attacks you're speaking of, and they thought the devices just kind of mechanically failed? Does that happen a lot?
Absolutely. And that was actually, it wasn't just a month, it was actually years. So ahead of it. And if they hadn't, I mean, they discounted some activities that did happen on that system because they were just failures or stuff that's happened. We've all been commissioning or working on systems and had a device not act right. So what do? You unplug it, plug it back in, hope everything's great. But when they went back and correlated those items and then looked and saw some activity in the systems around it, that started to raise some concerns. So absolutely. So what is this part of this? What do we want to take away from this? So what I want to talk about is this concept of unverified trust. So for a lot of reasons, we have been optimizing functionality, reliability, safety aspects, and cost in all of our systems. And the security aspects, if they're addressed, are usually thought to come under either physical security or the IT guys that take care of it. But the reality is that we have a lot of trust in all the different parts of our system or the ecosystem of how we put together these systems now. So from our suppliers, integrators, vendors, etc., and from the vendors to their suppliers, etc., all the way down the line, you can see that we have chains of unverified trust that an adversary can take advantage of to get something into a system. Why do I care about that? It's because we want to reinforce the concept that In the world we live in today, with the way that systems, the global supply chain, and the way systems are designed, implemented, and operated and maintained, there is every chance for an adversary to get in. And if the only thing we are relying on is that the cyber guy will catch it, um, we're going to have more of these bad days uh, that we've shown where we're starting to impact our critical functions day after day after day. So what does that mean? It means that we, as engineers and operations folks, need to be thinking about where do we have unverified trust and how can I maybe provide these critical functions, um, use technology in ways that even if any of them are compromised, I'm still getting my critical function out the door. So, unverified trust is again this blind reliance placed in people, processes, or technologies. And I just want to hit one more example real quick to kind of put a bow on this, and then we'll kind of open it up for questions. So, probably one of the most impactful uh, events that's happened in the last year that everyone should pay attention to was this Solarwinds supply chain attack. So, 2 or 3 years ago, most people wouldn't have understood what Solarwinds was at all. I mean, it is a software that helps people monitor and understand network performance. It's integrated in infrastructure, it's integrated in pretty much government, industry, et cetera, across the board. And it's ubiquitous and it's pretty much like wiring. Very few people understood anything about it, but it had a great market position and it was a very trusted component. Well, an adversary looked at that and said, wow, they are absolutely everywhere. And we believe, there was a multi-year campaign on the part of an adversary to get in to the development cycle of SolarWinds, to compromise that development cycle and inserting malware in, even to the point where they inserted something to test to see if it would make it all the way through their design, development, testing, and shipped out to the field process. They were able to do that. They ended up putting in malware into the systems. And so the updates that were delivered from SolarWinds with certificates and everything on them looked like had malware in them. They looked like a good update. And if you start to think about this that was SolarWinds from a network perspective, and this was around uh, access so that adversaries could go further. But imagine, if you will, some of the vendors that we rely on, whether it's Allen Bradley controllers or Schweitzer engineering software used to protect our electrical devices. I mean, think about these vendors that are ubiquitous. And if a nation state is going after these vendors and compromises it, and you have hundreds or your entire function is reliant on that, even if you don't immediately see an impact, if you found out today that XYZ vendors software was compromised and it was um, and had been for a time period and you were completely reliant on that vendor, would you want to continue operation? There'd be a lot of scrambling at that point, just trying to figure it out. But if we've done some of the thought work to say, where do I have some unverified trust? Where am I reliant on vendors or suppliers or others? And what would it mean to my operation and how I operate? Can I operate effectively even if it's compromised? Those kind of questions, those are not going to be answered by the cyber guy. Those are going to be answered by the people who design, install, operate, and maintain the systems that are out there. So the real thing that I'm trying to get across with this is it's all of our responsibilities to start thinking about how we provide critical functions. Those critical functions themselves provide a focus for what's important, and then we can use that to really tear apart where do I have reliances on technology, and if they could be um, compromised, what would that mean for providing my critical function? So I've just tried to introduce a few concepts for everyone. I do want to say that once you start thinking about this problem in this way, the tools and techniques that you can bring to bear are the same tools and techniques you use for most engineering and operation evaluations. It's just with a slightly different focus of security. So we can use almost all the same processes that we use for risk management in complex engineered systems. We just have a slightly different focus. And consequence driven cyber formed engineering is a methodology that helps break that down so that people can focus on exactly how do you do this and implement this in your processes. Um, the handouts that we have talk a little bit about CCE, what it is, how we focus it on what we term tier one or national security related challenges. And we also have some training options that are available to teach all the way down on how to do this, as well as we have an introduction that goes a little deeper than this webinar that explains a little bit more on what are some of the tools I can use to address some of these challenges. And that webinar or I think we're teaching a 4-hour class on March 23rd at in Baltimore, or I'm sorry, not Baltimore, in
Rockville,
Maryland,
in Rockville,
Rockville.
Maryland. Yep, that's going to be at
Rock,
the. It's going to be the on Wednesday, the 23rd at Sammy Capital Week. And if you haven't registered, I understand that the class 4-hour class is filling up fast. You may want to jump on there and take a look at that.
okay, I want to open it up for any questions that anybody has.
Okay. We have a question from Albert Romano. He said, or he asked, when assessing a critical operational system to map out processes and identify potential or possible vulnerabilities, how do you address the many interdependencies that often exist within a complex system?
So what we do is what we call a system of system analysis. So in the CCE process, first off, we have to provide focus. You can't look at everything. Um, you have to focus in. I mean, from a security perspective, many of the hygiene things that we do are spread at that lower layer. And so we call cyber hygiene all those good practices that you do, following standards, doing your checklists, making sure your firewall rules. That's the floor of security that you stand on. But real security is when you provide focus, what's important for my function, what's the worst thing that can happen, what's my bad day, and then doing a system of systems analysis on how I provide the critical function related to that bad day. That's how we end up. We use basically system engineering principles to break that down, understand it, and understand all those relationships.
Great. Thank you, Curtis. One of the other questions that I had is, this seems like, when you're talking about a critical function and you're talking about a facility or an operation, this seems like a big thing with a lot of people that are involved. And maybe if it's greenfield, you're starting things up. If it's brownfield, you may be dealing with stuff that, people put in place decades ago. How do you bring the right team together to make this kind of thing happen?
So it really is a some people would term this an assessment, and it really isn't. The way we approach this is it is a training opportunity. So when we work with an entity, we provide an introductory training to whatever operation, and we're going to pull mission owners, people who design and build, um, the people who operate and maintain. We pull a team together from those organizations. Um, we come up with what the critical function is, what the worst case scenarios are, do that system to system analysis, come up with how would an adversary exploit that, and then really talk about what can you do about it. And preferably when we talk about what you can do about it, it's how do I take that off the table by changing either how the system is engineered or how it's operated. And those kind of things, regardless of whatever's going on in the cyber world, when I'm assuring that critical function through the engineering or operation lens, that's what we're doing. And we're training the folks who do that over the course of anywhere from a few months to a year on how exactly to do that using the methodology.
Thank you, Curtis. That's a great dovetail into discussing some of our licensed partners that are actually helping teach CCE. And it just so happens that these licensed partners, licensed with INL, are also sustaining members of SAMI. So we have Black and Veatch, and then we also have the 1898 company, part of Burns and McDonnell, and then West Yost. And I don't know, Curtis, if you want to kind of touch on what that means with from a licensed partner perspective.
So what that really means is we've had a few engineering companies that have come forward, and they're going to focus on how do they incorporate engine or cyber into their engineering processes as an offering. So working for West Yost, it's in the water sector. So for the water sector, we've had attacks, Oldsmar, Florida, where you've had entities doing watering hole attacks and potentially impacting water for communities. West Yost is a company that's now looking at those installations, looking at the technology that they're using, and recommending how do I engineer out or mitigate some of the unverified trust that I'm putting in place. Burns Mac and Black and Veatch do all kinds of engineering across the board, from power plants to natural gas pipelines to military bases to anything across the board. And they've all been to training. They're starting to participate to really help take that aggressor mindset, go in and look at processes and how critical functions are provided, and really understand what they do about that from an engineering or operations perspective to take it off the table, regardless of whether an adversary is in their systems.
That's great. Thank you, Curtis. Looks like we're on time here and on track to end. We have a little bit of information here for anyone that's interested in learning more about the CCE. And so we have a link to the website, as well as an email address for the CCE program and INL. And again, if you don't catch this now, I believe the slides will be up there, and this webinar will be recorded so you can get the information later. And lastly, we want to thank everyone. We want to thank the Resilience Committee for giving us the opportunity to talk about cyber-enabled sabotage and CCE. And we want to thank everyone for their time attending this webinar. And if you have any questions, please feel free to reach out to us, and we'll do our best to answer them.
Absolutely. Thank you all.
Thank you, everyone.